Dear students, my name is Dr. Amir Fawad Zahoor, and in this video we will talk about thiophene. Thiophene is 5-membered sulfur-containing heterocycle, and like furan, it has all the atoms coplanar. First we see the synthesis. First method for the synthesis is Fiesselmann synthesis. In this reaction, alkyl thioglycolates are used, and they are allowed to react with beta chlorovinyl aldehydes and base such as piperidine can be used. And as a result we get thiophene derivatives. So mechanism: in the first step, this thioglycolate reacts with base and we get this one minus HB positive, and this reacts with beta chlorovinyl carboxylaldehyde, and as a result we get this. And in the next step this comes back here, and Cl is eliminated, chloride minus Cl negative, and here would be same, and now we get this one, and this can react with, here proton can be eliminated using base, and this interlead is formed. Negative, and this interlead attacks on this aldehyde, intramolecular aldol reaction, and because we have proton present in the system, so we get this, and in the last step water molecule is eliminated in the presence of base, because base takes this proton, and we get thiophene derivatives. So this is our molecule which can be put here. So first method is Fiesselmann synthesis, and in this case we can use alkyl thioglycolates which would react with beta chlorovinyl aldehydes, and as a result thiophene derivatives are obtained. And this is the mechanism which we have done, and this is the proposed mechanism. And now we see another method. Okay, next method is Gewald synthesis. In this method alpha cyanoacetates are used, and they are allowed to react with alpha methylene containing carbonyl compounds, and we get Thiophene derivatives, and this reaction takes place in the presence of sulfur. So we see the mechanism. In the first step, base is added, which takes the proton from this position, and as a result enolate is formed. And this enolate reacts with the carbonyl compound, here, and we get this, and this negative charge takes proton which is in the solvent, and as a result this is produced. Base will take the proton from here, and as a result water molecule would be eliminated, and we will get this compound. And again, since base is present in the system, this proton can be abstracted, and we will get the corresponding carbanion. And this carbanion would now react with sulfur. So we have sulfur here, that is S8. So it will attack here, and we will get S negative. So we will get this, and this will attack here, and this will attack here. So we will get this one, and this anion will take the proton from the reaction mixture, and we will get this. And now in the end, base will take this proton, this will shift here, this will shift here, and here we will have a negative charge. And this will take the proton from the base, protonated base, and as a result we will get this molecule. So this is our thiophene derivative, and this is the mechanism. I hope you have understood this mechanism. Now we see the next method. Next method is Hinsberg synthesis. And this method involves the reaction of 3-thiopentane dioic acids with carbonyl compounds, 1,2 carbonyl compounds, and here we have active methylene group, here we have active methylene group. So both of these react and double aldol condensation takes place in the presence of base, which is sodium alkoxide, for example, and as a result we get these derivatives of thiophene. And these esters can be hydrolyzed via using base, then H3O positive and decarboxylation. So we would get thiophene derivatives. So these are the methods for the synthesis of thiophene. Now we can see some reactions. First reaction is electrophilic substitution reaction. The basic mechanism is same for the electrophilic substitution reaction. Different types of electrophilic substitution reactions can be explained. Okay, these are the electrophilic substitution reactions of thiophene. In general, we get two substituted product, and if the reaction time is extended, we get 2,5 disubstituted products in general. However, in case of nitration, 2,4 disubstituted product is obtained. So chlorination is carried out in the presence of chlorine, or we can use SO2Cl2, and bromination can be carried out in the presence of bromine in acetic acid, or we can use N-bromosuccinamide as well. And for nitration, concentrated nitric acid and acetic acid at lower temperature 10 degrees centigrade is used. For sulfonation, 96% sulfuric acid at 30 degrees centigrade is used. And acylation is carried out using acid chloride plus tetrachlorotin, and this reaction results in 2-acyl thiophene, whereas alkylation reactions of thiophene give poor yield. Another reaction is metallation reaction, or we can say acid-base reaction, because proton from here is abstracted by N-butyl group and it converts in N-butane, and we get metallation, or it can also be referred as acid-base reaction. So these were electrophilic substitution reactions. Now we see other examples. Next are addition reactions. Thiophene can give Diels-Alder reaction and behaves as 1,3-diene, but its reactivity is lower than furan. So generally we use higher temperature or pressure. This reaction may take place at 160 degrees centigrade, and we get this product. And it can lose sulfur to give rise to benzene derivative. This can also react with maleic anhydride, in dichloromethane, and pressure is used to carry out this reaction, and we get this product. Whereas if it is made to react with diisomethane in the presence of Cu2Br2, we get 2 plus 1 cycloaddition across 2 carbon 3, and if the reaction is carried out using dicyanoacetylene, 2 plus 2 cycloaddition takes place, and we get this product. So these are addition reactions. Now we see ring opening reactions. Thiophenes do not undergo ring opening reactions as in case of furan or pyrrole. Rather, they need special reagents for ring opening reactions because they cannot be polymerized or hydrolyzed. And for example, we have this reaction. In this special reagent is used. In the presence of phenyl magnesium bromide, and sulfur is eliminated, and we get this product as a result of ring opening. And if the reaction takes place with Raney nickel, so reductive desulfurization takes place because Raney nickel during its preparation absorbs hydrogen, and as a result we get this product. Now if we see the application of thiophene, its application is preparation of muscone, which is a primary contributor to the order of musk. In the first step, N-butyl lithium is reacted with 3-methyl thiophene, and we get this. Now this is made to react with a special dibromide, which results in the formation of this halide. And this is further treated with potassium cyanide, and resulting cyano group which installs here is hydrolyzed with water, acidic conditions, and as a result this one, and this is further reacted the presence of trifluoroacetic anhydride and phosphoric acid, acetonitrile as solvent, and we get acylation intramolecular. This intramolecular acylation reaction, and in the end it is treated with ranitidine and ethanol, and we get this one, which is positive negative muscone. So I hope this is clear to you, and I can repeat it again. In the first step, n-butyl lithium takes proton from here, and as a result we get carbanion, which reacts with this special dihalide, and one bromo group is replaced. As a result we have one left. This bromo group is replaced in the next step using cyanide, and this cyano group when installed here can be hydrolyzed using acidic condition to get the corresponding carboxylic acid, and this carboxylic acid under these conditions, trifluoroacetic anhydride, phosphoric acid and acetonitrile, gives intramolecular acylation reaction, and it can be further treated with ranitidine in ethanol as solvent to give positive negative muscone as the product. So I hope that this is all clear to you, and if you have any questions or queries you can leave them in comment box. Thanks.